Hey there, hopefully you guys just finished the friction lab and now you're ready to kind of talk about the results and let's see what went on. So first I've drawn a little example of your setup. You had an eraser and you connected a force sensor through a lab quest and you pulled on the force sensor to move the eraser, and we actually even went so far as to have weights on top of the eraser. And we were looking at several factors to determine what exactly is involved with the force of friction. So let's look at a couple of the results here and see what was going on. First, I want to address your graphs. And your graph was for force versus time. And so what's happening is, as you increase the force, nothing happened, and then all of a sudden the force leveled off. Now what was going on here is that right at that point the eraser started moving. So the eraser started moving, and from there the force was pretty constant. So let's talk about what was going on there. While you were applying more and more force, the eraser just sat there. So there was no change in motion going on, which tells us that the net force on the eraser in that situation, if we were to look at a free body diagram of the eraser, you have, this is the force on the eraser from you. So this is you pulling on the eraser, and then you have the force of friction. And during this time, whatever force you were pulling on, friction was actually matching that. Since there was no change in motion, those must be equal, which means the amount of friction on the object was constantly changing to match whatever force you put on it right up until this point. And at that point the eraser started moving. So once you got to right here, the force that you were supplying was greater than the amount of friction between this object and whatever it was rubbing against, so a desk or the counter. So at that point, right, if we're very careful and we measure that out, you could find the amount of friction needed to get that started moving. So that's the maximum amount of friction that the object can generate just sitting there. And this has a name. It's called static friction. So the static friction is the friction before this thing actually starts moving between the surface and whatever the object is. And you have to overcome that static friction to get the object to start moving. And from this graph you can actually determine the force of static friction between your eraser and slotted mass system and whatever you were dragging it across. Now, once this thing started moving, I said to drag it at a constant speed. Constant speed means that the forces are balanced. So at this point, in fact, if we want to get really technical, you probably should have seen a small reduction in force, so it would overshoot a little bit, and then you have this force of friction, which we would call, in this case, sliding friction, or kinetic friction would be another way to talk about this. So we have the static friction and then the sliding friction afterwards. And the way this works, the reason I told you that there may even be, and should actually be, a part where this overshoots a little bit and then less force is needed, is that generally the force of static friction is going to be larger than the force of sliding friction. So it takes more to get the thing started than it does to keep it going. You've probably encountered this if you've ever tried to move a big piece of furniture, like say a couch, particularly over carpet. Like you push on it and you push on it and it's really hard to push and it doesn't go anywhere. Finally you get enough force on it and then it's easier to keep it moving once it starts. That's because that static friction is actually greater than the sliding friction. So that's one of the things you should have seen. Now, next up, for the same surface, so we didn't change the type of surface, we just changed the amount of mass on there. And what you should have found is that if I put these on the same graph, is that if this is the really heavy eraser, so the one with lots and lots and lots of weight on it, it would look different than the lighter eraser. So what this tells us is that something about adding more mass to that system, so having more mass on it, means that the force of friction is greater. Now we have to be careful here. There's something very interesting going on that I didn't really have you tease out in the experiment. It's tempting to say that the force of friction is just dependent on the mass of the system. However, that's not entirely correct. The force of friction is actually dependent on the normal force. So that is, the greater the normal force on the object, the greater the amount of friction. Now if we increase the mass, that means this eraser will push harder down on the desk or on the counter, and consequently, Newton's third law tells us that the counter will push harder back on it. So really, the more mass we put on here, the greater the normal force. But that is a very important result. More normal force means more friction. So again, the heavier object, because of the greater normal force, will produce more friction. Now, the other one to look at will be the result of different surfaces on there. So if we were to look, we would see the same result here. So I'm going to say this was the plastic on the back of the eraser, so when you had it upside down with the eraser part pointing upward. And then this is when you slid it across with paper. So notice that the paper generated more friction than the plastic did. Now the reason for this is not only does friction depend on the normal force involved, it depends on the type of surface as well. Different surfaces will produce different amounts of friction, and this is taken into account using what's called a coefficient of friction. And each different object in contact with whatever other object is going to have a different coefficient of friction. So objects with a very high coefficient of friction are going to have more friction. Low coefficients of friction produce smaller ones. And so our equation, when it all boils down to it, is that our force of friction is equal to the coefficient of friction, for which we use the symbol we call mu. It kind of looks like a U with a tail on it. You can also think of it as being an M. However you need to think of it, it's just a Greek letter called mu. So the force of friction is equal to the coefficient of friction, mu, times the normal force. So again, greater coefficient of friction means more friction. Greater normal force means more friction, and vice versa. Less of this produces less friction, less normal force, less friction. So hopefully you saw that in your lab and now have a pretty good handle on it.